Welcome to this Python course. Sometimes, when the code alone doesn't provide context or clarify intent, the developer may write extra descriptions. These descriptions are called code comments. Comments in Python start with a hash character and extend to the end of the physical line. A comment may appear at the start of a line or following whitespace or code, but not within a string literal. A hash character with a string literal is just a hash character. This is not a comment because it's inside quotes. When we execute the code, we can see the comments were ignored. The syntax of the Python programming language is the set of rules that define how a Python program will be written and interpreted by both the runtime system and by human readers. Keywords. Python has 35 keywords or reserved words, and they cannot be used as identifiers. Keywords are predefined reserved words used in programming that have special meanings to the compiler. Here is a list of these keywords we will use later during the tutorial. Indentation. Indentation refers to the spaces at the beginning of a code line, where in other programming languages, the indentation in code is for readability only. The indentation in Python is very important. Python uses indentation to indicate a block of code. Python uses white spaces to delimit control flow blocks. While both space and tab characters are accepted as forms of indentation and any multiple spaces can be used, spaces are recommended, and 4 spaces as in the above examples are recommended and by far the most commonly used. Best practice when setting up your Python environment. You can install Python directly in your operating system, but the best practice is to install it in an isolated environment like a Docker container or Python virtual environment. During this tutorial, we will install Python in a Docker container using a GitHub repository as our source. If you don't understand, don't worry, I will show you how. You will need to install Docker to use it as a container, GitHub as a repository of code, Visual Studio as an IDE, and Dev extension to use Docker from Visual Studio. Due to time limitations, we will not cover these installations in this video. Still, we will do a video exclusively installing each of these components and include them in the video description. Python setup in Docker. Open Docker and click on Dev Environment. Create a new environment and get started. You can set up a Git repo or use a folder on your local computer. We will use a previously created GitHub repository by copying the link here. Give it a name and press Continue. Press Continue and then Done. Click Open VS Code to open Visual Studio directly from the container. By default, Python 3 is installed, so you need to verify it by running Python 3 version. To ensure your system is up to date, you can run apt-get update. The interpreter acts as a simple calculator. You can type an expression at it and it will write the value. Expression syntax is straightforward. The operators plus, subtraction, multiplication, and division work just like in most other languages. Parentheses can be used for grouping. Division always returns a floating point number. Classic division returns a float. Floor division discards the fractional part. The percent operator returns the remainder of the division. Floor quotient asterisk divisor plus remainder. Five squared. 2 to the power of 7. There is full support for floating points. Operators with mixed-type operands convert the integer operand to a floating point. Now, let's print the operations to see the results. Besides numbers, Python can also manipulate strings, which can be expressed in several ways. They can be enclosed in single or double quotes with the same result. A backslash can be used to escape quotes. If you don't want characters prefaced by a backslash to be interpreted as special characters, you can use raw strings by adding an R before the first quote. String literals can span multiple lines. One way is using triple quotes. The end of lines are automatically included in the string, but it's possible to prevent this by adding a backslash at the end of the line. Produces the following output. Strings can be concatenated with a plus operator repeated with the asterisk. Two or more string literals next to each other are automatically concatenated. This feature is handy when you want to break long strings like this. This only works with two literals, not variables or expressions. Cannot concatenate a variable and a string literal. If you want to concatenate variables or a variable and a literal, use plus. Strings can be indexed, with the first character having an index of 0. Indices may also be negative numbers to start counting from the right. In addition to indexing, slicing is also supported. While indexing is used to obtain individual characters, slicing allows you to obtain substring. Slice indices have useful defaults. An omitted first index defaults to 0, and an omitted second index defaults to the size of the string being sliced. One way to remember how slices work is to think of the indices as pointing between characters, with the left edge of the first character numbered 0, then the right edge of the last character of a string of n characters has index n. Attempting to use too large index will result in an error. However, out-of-range slice indices are handled gracefully when used for slicing. Python strings cannot be changed. They are immutable. Therefore, assigning to an index position in the string results in error. The built-in function len returns the length of a string. Python knows several compound data types used to group other values. The most versatile is the list, which can be written as a list of comma-separated values or items between square brackets. Lists may contain items of different types, but usually, the items all have the same type. Lists can be indexed and sliced like strings, and all other built-in sequence types. All slice operations return a new list containing the requested elements. This means that the next slice returns a shallow copy of the list. Lists also supports operations like concatenation. Unlike immutable strings, lists are mutable type. That is, it is possible to change their content. You can also add new items at the end of the list using the append method. We will see more about methods later. Assignments to slices is also possible, which can even change the list size or clear it entirely. Replace some values. Now remove them. Clear the list by replacing all the elements with an empty list. The built-in function len also applies to lists. It is possible to nest lists and create lists containing other lists. The while loop executes as long as the condition remains true. In this case, a less than 10. The test used in the example is a simple comparison. The standard comparison operators are written as less than, greater than, equal to, less than or equal to, greater than or equal to, and not equal to. The print function writes the value of the arguments it is given. Strings are printed without quotes, and a space is inserted between items so we can format things nicely like the next example. The keyword argument end can be used to avoid the new line after the output or end the output with a different string. The most well-known statement is the if statement. There can be 0 or more elif parts, and the else part is optional. The keyword elif is short for else if and is useful to avoid excessive indentation. An if-elif sequence is a substitute for the switch or case statements found in other languages. Python's for statements iterates over the items of any sequence, in the order that they appear in the sequence. Create a sample collection. Code that modifies a collection while iterating over that same collection can be tricky to get right. Instead, It is usually more straightforward to loop over a copy of the collection or to create a new collection. Strategy: iterate over a copy. Strategy: create a new collection. If you do need to iterate over a sequence of numbers, the built-in function range comes in handy. It generates arithmetic progressions. The given endpoint is never part of the generated sequence. Range generates 10 values, the legal indices for items of a sequence of length 10. It is possible to let the range start at another number or to specify a different increment. To iterate over the indices of a sequence, you can combine range and len as follows. In most cases, however, it is convenient to use the enumerate function that we will discuss in more detail in chapter looping techniques. In many ways, the object returned by range behaves as if it is a list, but in fact it isn't. It is an object which returns the successive items of the desired sequence when you iterate over it, but it doesn't really make the list, thus saving space. Later we will see more functions that return iterables and take iterables as arguments. In chapter data structures, we will discuss in more detail about list. The break statement breaks out the innermost closing for or while loop. Loop statements may have an else clause. It is executed when the loop terminates through exhaustion of the iterable, or when the condition becomes false. But when the loop is terminated by a break statement, this is exemplified by the following loop, which searches for prime numbers. When used with a loop, the else clause has more in common with the else clause of a try statement than it does with that of if statements. A try statement's else clause runs with no exception occurs. A loop's else clause runs with no break occurs. In chapter Statements and Exceptions, we will discuss in more detail about try statements. The continue statement continues with the next iteration of the loop. The pass statement does nothing. It can be used when a statement is required syntactically, but the program requires no action. This will be busy wait for keyboard interruption. This is commonly used for creating minimal classes. Another place pass can be used is as a placeholder for a function or conditional body when you are working on a new code, allowing you to keep thinking at a more abstract level. The pass is silently ignored. we can create a function that writes the Fibonacci series to an arbitrary boundary. The keyword def introduces a function definition. It must be followed by the function name and the parenthesized list of formal parameters. The statements that form the body of the function start at the next line and must be indented. Now call the function we just defined. A function definition associates the function name with the function object in the current symbol table. The interpreter recognizes the object pointed to by that name as a user-defined function. Other names can also point to the same function object and can also be used to access the function. It is simple to write a function that returns a list of the numbers of the Fibonacci series instead of printing it. Default argument values. The most useful form is to specify a default value for one or more arguments. This creates a function that can be called with fewer arguments than it is defined to allow. This function can be called in several ways: giving only the mandatory argument, giving one of the optional arguments, or even giving all arguments. The default values are evaluated at the point of function definition in the defining scope. The default value is evaluated only once. This makes a difference when the default is a mutable object, such as a list, dictionary, or instances of most classes. For example, the following function accumulates the arguments passed to it on subsequent calls. If you don't want the default to be shared between subsequent calls, you can write the function like this instead. Functions can also be called using keyword arguments of the form keyword equals value. For instance, the following function accepts one required argument, voltage, and three optional arguments, state, action, and type. This function can be called in the following ways. But also all the following calls would be invalid. When a final formal parameter of the form ***name is present, it receives a dictionary containing all keyword arguments except for those corresponding to a formal parameter. This may be combined with a formal parameter of the form ***name, which receives a tuple containing the positional arguments beyond the formal parameter list. ***name must occur before ***name. For example, if we define a function like this, it can be called like this. and of course, it would print. Note that the order in which the keyboard arguments are printed is guaranteed to match the order in which they were provided in the function call. By default, arguments may be passed to a Python function either by position or explicitly by keyword. For readability and performance, it makes sense to restrict the way arguments can be passed, so that a developer need only look at the function definition to determine if items are passed by position or keyword, or by keyword. A function definition may look like, where slash and asterisk are optional. If used, these symbols indicate the kind of parameter by how the arguments may be passed to the function: positional only, positional or keyword, and keyword only. Keyword parameters are also referred to as named parameters. Consider the following example function definitions, paying close attention to the markers slash and asterisk. The first function definition, standard arg, the most familiar form, places no restrictions on the calling convention, and arguments may be passed by position or keyword. The second function, pos-only arg, is restricted to only use positional parameters as there is a slash in the function definition. The third function, keyword-only args, only allows keyword arguments as indicated by an asterisk in the function definition. And the last uses all three calling conventions in the same function definition. But using slash, positional-only arguments, it is possible since it allows name as a positional argument and open apostrophe name, close apostrophe as a key in the keyword arguments. In other words, the names of positional-only parameters can be used in asterisk keywords without ambiguity. Small anonymous functions can be created with the lambda keyword. This function returns the sum of its two arguments, lambda a, b, colon a plus b. Lambda functions can be used wherever function objects are required. They are syntactically restricted to a single expression. Semantically, they are just syntactic sugar to a normal function definition. Like nested function definitions, lambda functions can reference variables from a containing scope. The above examples uses lambda expressions to return a function. Another use is to pass a small function as an argument.
If you're watching this video tutorial, you have invested a substantial amount of time to arrive at a solution to solve a challenge that keeps you up at night. Still, you'll probably have to repeat it again in the future. You can avoid that headache by storing the steps involved in a safe location for future use. Using MyStarlog, you can use a variety of methods like programming language codes, notes, texts, links, or any other source type that you used during your original research to find the solution. With MyStarlog, you can log your solutions in the exact way that they worked and find all the steps in one place next time.
Here are some conventions about the content and formatting of documentation strings. The first line should always be a short, concise summary of the object's purpose. For brevity, it should not explicitly state the object's name or type, since these are available by other means, except if the name happens to be a verb describing a function's operation. This line should begin with a capital letter and end with a period. If there are more lines in the documentation string, the second line should be blank, visually separating the summary from the rest of the description. The following line should be one or more paragraphs describing the object's calling conventions, its side effects, etc. Here is an example of a multi-line docstring. The list data type has some or more methods. Here is an example that uses most of the list methods. You might have noticed the methods like insert, remove, or sort that only modify the list have no return value printed. They return the default none. Another thing you might notice is that not all data can be sorted or compared. The list methods make it very easy to use the list as a stack, where the last element added is the first element retrieved. Last in, first out. To add an item to the top of the stack, use append. To retrieve an item from the top of the stack, use pop without an explicit index. It is also possible to use a list as a queue, where the first element added is the first element retrieved. First in, first out. However, lists are not efficient for this purpose. While appends and pops from the end of the list are fast, doing inserts or pops from the beginning of a list is slow, because all of the other elements have to be shifted by one. To implement a queue, use collections.dq, which was designed to have fast appends and pops from both ends. List comprehensions provide a concise way to create lists. Common applications are to make new lists where each element is the result of some operations applied to each member of another sequence or iterable, or to create a subsequence of those elements that satisfy a certain condition. For example, assume we want to create a list of squares like this. Note that this creates, or overwrites, a variable named x that still exists after the loop completes. We can calculate the list of squares without any side effects using, for example, or equivalently, which is more concise and readable. A list comprehension consists of brackets containing an expression followed by a for clause, then 0 or more for or if clauses. The result will be a new list resulting from evaluating the expression in the context of the for and if clauses which follows it. For example, this list comp combines the elements of the two lists if they are not equal. And it's equivalent to. Note how the order of the for and if statements is the same in both these snippets. If the expression is a tuple, for example, the x and y in the previous example, it must be parenthesized. The initial expression in a list comprehension can be any arbitrary expression, including another list comprehension. Consider the following example of a 3x4 matrix implemented as a list of 3 lists of length 4. The following list comprehension will transpose rows and columns. As we saw in the previous section, the inner list comprehension is evaluated in the context of the for that follows it. So this example is equivalent to which in turn is the same as this example. In the real world, you should prefer built-in functions to complex flow statements. The zip function would do a great job for this use case. There is a way to remove an item from a list given its index instead of its value, the del statement. This differs from the pop method which returns a value. The del statement can also be used to remove slices from a list or clear the entire list, which we did earlier by assignment of an empty list to the slice. Del can also be used to delete entire variables. We saw that lists and strings have many common properties, such as indexing and slicing operations. There are two examples of sequence data types. There is also another standard sequence data type, the tuple. A tuple consists of a number of values separated by commas. For instance, as you see, on output tuples are always enclosed in parentheses, so that nested tuples are interpreted correctly. It is not possible to assign to the individual items of a tuple. However, it is possible to create tuples which contain mutable objects such as a list. Sequence unpacking requires that there are as many variables on the left side of the equal sign as there are elements in the sequence. Empty tuples are constructed by an empty pair of parentheses. A tuple with one item is constructed by following a value with a comma. Python also includes a data type for sets. A set is an unordered collection with no duplicate elements. Basic uses include membership testing and eliminating duplicate entries. Set objects also support mathematical operations like union, intersection, difference, and symmetric difference. Curly braces or set function can be used to create sets. Note: to create an empty set, you have to use set parentheses and not curly braces. The latter creates an empty dictionary, a data structure that we discuss in the next section. Similarly to list comprehensions, set comprehensions are also supported. Another useful data type built into Python is the dictionary. Unlike sequences, which are indexed by a range of numbers, dictionaries are indexed by keys, which can be any immutable type. Strings and numbers can also be keys. It is best to think of a dictionary as a set of key-value pairs, with the requirement that the keys are unique. Here is an example of using a dictionary. The dict constructor builds dictionaries directly from sequences of key-value pairs. In addition, dict comprehensions can be used to create dictionaries from arbitrary key and value expressions. When the keys are simple strings, it is sometimes easier to specify pairs using keyword arguments. When looping through dictionaries, the key and corresponding value can be retrieved at the same time using the items method. When looping through a sequence, the position index and corresponding value can be retrieved at the same time using the enumerate function. To loop two or more sequences at the same time, the entries can be paired with the zip function. To loop over a sequence in reverse, first, specify the sequence in a forward direction and then call the reversed function. To loop over a sequence in sorted order, use the sorted function, which returns a new list while leaving the source unaltered. Using set on a sequence eliminates duplicate elements. The use of sorted in combination with set over a sequence is an idiomatic way to loop over unique elements of a sequence in sorted order. It is sometimes tempting to change a list while you are looping over it. However, it is often simpler and safer to create a new list instead. A module is a file containing Python definitions and statements. The file name is the module name with the suffix .py appended. Within a module, the module's name, as a string, is available as the value of the global variable name. For instance, let's create a file called fibo.py in the current directory with the following contents. Now let's import this module with the following command. If you intend to use a function often, you can assign it to a local name. There is a variant of the import statement that imports names from a module directly into the importing module's namespace. There is even a variant to import all names that a module defines. This imports all names except those beginning with an underscore. If the module name is followed by as, then the name following as is bound directly to the imported module. It can also be used when utilizing from with similar effects. When you run a Python module with the Python fibo.py arguments, the code in the module will be executed just as if you imported it, but with the name set to main. That means that by adding this code at the end of your module, you can make the file usable as a script as well as an imported module, because the code that parses the command line only runs if the module is executed as the main file. If the module is imported, the code is not run. This is often used either to provide a convenient user interface to a module or for testing purposes. Running the module as a script executes a test suite. The built-in function dir is used to find out which names a module defines. It returns a sorted list of strings. Without arguments, dir lists the names you have defined currently. Note that it all lists all types of names, variables, modules, functions, etc. dir does not list the names of built-in functions and variables. If you want a list of those, they are defined in the standard module built-ins. Users of the package can import individual modules from the package. For example, this loads the submodule sound.effects.echo. It must be referenced with its full name. An alternative way of importing the submodule is, yet another variation is to import the desired function or variable directly. Again, this loads the submodule echo, but this makes its function echo filter directly available. Note that when using from package import item, the item can be either a submodule or subpackage of the package, or some other name defined in the package, like a function, class, or variable. Although certain modules are designed to export only names that follow certain patterns when you use import asterisk, it is still considered bad practice in production code. So far, we've encountered two ways of writing values: expression statements and a print function. Often, you'll want more control over the formatting of your output than simply printing space-separated values. There are several ways to format output. To use formatted string literals, begin a string with F before the opening quotation mark or triple quotation mark. Inside this string, you can write a Python expression between open curly brace and close curly brace characters that can refer to variables or literal values. The stir.format method of strings requires more manual effort. You'll still use open curly brace and close curly brace to mark where a variable will be substituted and can provide detailed formatting directives, but you'll also need to provide the information to be formatted. When you don't need fancy output but just want a quick display of some variables for debugging purposes, you can convert any value to a string with the repr or stir functions.
Let's suppose you're doing a lot of research and trying to find the best solution to a problem. This trial and error can take hours, days, or even weeks to complete. Then, in the future, you find yourself spending time repeating the same task because you forgot or lost each step that was involved in finding that original solution. Use your time wisely. not searching for a solution that you have already solved in the past. By logging it into My Star Log, you can be reassured that your solutions are easily available in a safe location. Save yourself an abundance of time on that same task. With My Star Log, you can log your solutions in the exact way that they work and find all the steps in one place next time.
Formatted string literals let you include the value of Python expressions inside the string by prefixing the string with f and writing expressions. An optional format specifier can follow the expression. This allows greater control over how the value is formatted. The following example rounds pi to 3 places after the decimal. Passing an integer after the colon symbol will cause that field to be a minimum number of characters wide. This is useful for making columns line up. Other modifiers can be used to convert the value before it is formatted. Exclamation symbol A applies ASCII, exclamation symbol S applies stir, and exclamation R applies repr. The equal symbol specifier can be used to expand an expression to the text of the expression, an equal sign, then the representation of the evaluated expression. Basic usage of the stir.format method looks like this. The brackets and characters within them, called format fields, are replaced with the objects passed into the stir.format method. A number in the brackets can be used to refer the position of the object passed into the stir.format method. If keyword arguments are used in the stir.format method, their values are referred to by using the name of the argument. Positional and keyword arguments can be arbitrarily combined. If you have a really long format string that you don't want to split up, it would be nice if you could reference the variables to be formatted by name instead of by position. This can be done by simply passing the dict and using square bracket symbols to access the keys. This could also be done by passing the table dictionary as keyword arguments with the *** notation. This is particularly useful in combination with the built-in function vars, which returns a dictionary containing all local variables. As an example, the following lines produce a tidily aligned set of columns, giving integers in their squares and cubes. Here's the same table of squares and cubes formatted manually. There is another method, stir.zfill, which pads a numeric string on the left with zeros. It understands about plus and minus signs. The percent operator, modulo, can also be used for string formatting. Given string and percent values, instances of percent and string are replaced with 0 or more elements of values. Open method returns a file object and is most commonly used with 2 positional arguments and 1 keyword argument. The first argument is a string containing the file name. The second argument is another string containing a few characters describing the way in which the file will be used. Mode can be R, W, and A. R+ opens the file for both reading and writing. It is good practice to use the with keyboard when dealing with file objects. If you're not using the with keyboard, then you should call f.close to close the file immediately and free up any system resources used by it. To read the file's contents, call f.read, which reads some quantity of data and returns it as a string. If the end of the file has been reached, f.read will return an empty string. f.readLine reads a single line from the file. For reading lines from a file, you can loop over the file object. f.write writes the contents of string to the file, returning the number of characters written. The JSON format is commonly used by modern applications to allow for data exchange. Many programmers are already familiar with it, which makes it a good choice for interoperability. If you have an object X, you can view its JSON string representation with a simple line of code. So if F is a text file object opened for writing, we can do this. To decode the object again, if F is a binary file or text file object which has been opened for reading. Until now, error messages haven't been more than mentioned, but if you have tried out the examples, you have probably seen some. There are at least two distinguishable kinds of errors: syntax errors and exceptions. Syntax errors, also known as parsing errors, are perhaps the most common kind of complaint you get while you're still learning Python. Even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. Most exceptions are not handled by programs, however, and result in error messages are shown here. It is possible to write programs that handle selected exceptions. Look at the following example, which asks the user for input until a valid integer has been entered. The most common pattern for handling exception is to print or log the exception and then re-raise it. The try except statement has an optional else clause, which when present must follow all except clauses. Exception handlers do not handle only exceptions that occur immediately in the try clause, but also those that occur inside functions that are called even indirectly in the try clause. The raise statement allows the programmer to force a specified exception to occur. For example, if you need to determine whether an exception was raised but don't intend to handle it, a simpler form of the raise statement allows you to re-raise the exception. If an unhandled exception occurs inside an except section, it will have the exception being handled attached to it and included in the error message. This can be useful when you are transforming exceptions. It also allows disabling automatic exception chaining using the from none idiom. The try statement has another optional clause which is intended to define cleanup actions that must be executed under all circumstances. If a finally clause is present, the finally clause will execute as the last task before the try statement completes. The finally clause runs whether or not the try statement produces an exception. A more complicated example: some objects define standard cleanup actions to be undertaken when the object is no longer needed, regardless of whether or not the operation using the object succeeded or failed. The with statement allows objects like files to be used in a way that ensures they are always cleaned up promptly and correctly. This is an example demonstrating how to reference the different scopes and namespaces, and how global and non-local affect variable binding. The output of the example code is the simplest form of class definition looks like this. Class object supports two kinds of operations: attribute references and instantiation. Attribute references use the standard syntax used for all attribute references in Python. Class instantiation uses function notation. Just pretend that the class object is a parameterless function that returns a new instance of the class. When a class defines an init method, class instantiation automatically invokes init for the newly created class instance. Of course, the init method may have arguments for greater flexibility. In that case, arguments given to the class instantiation operator are passed on to init. Generally speaking, instance variables are for data unique to each instance, and class variables are for attributes and methods shared by all instances of the class. For example, The tricks list in the following code should not be used as a class variable because just a single list would be shared by all dog instances. Correct design of the class should use an instance variable instead. If the same attribute name occurs in both an instance and in a class, then both attribute lookup prioritizes the instance. Any function object that is a class attribute defines a method for instances of that class. It is not necessary that the function definition is textually enclosed in the class definition. Assigning a function object to a local variable in the class is also okay. Methods may call other methods by using method attributes of the self argument. Of course, a language feature would not be worthy of the name class without supporting inheritance. The syntax for a derived class definition looks like this. The name base class name must be defined in a scope containing the derived class definition. Python supports a form of multiple inheritance as well. A class definition with multiple base classes looks like this. Private instance variables that cannot be accessed except from inside an object don't exist in Python. However, there is a convention that is followed by most Python code, a name prefixed with an underscore. Name mangling is helpful for letting subclasses override methods without breaking interclass method calls. Thanks for watching.